Hi, my name is Jan Behrens, and I'd like to show you as fast as it is possible what is CADvent. CADvent from Lindab is a three-dimension design tool based on AutoCAD. CADvent is made to design complete ventilation solutions for drafting, design, product selection, calculation, including pressure drop, acoustic and balancing calculations. You can analyze the system afterwards. You can make bill of materials at the end. And the good thing is everything is based on real values. What you can draw, you can build is our motto. And that means all components used in CADvent are real sizes and real connection informations. It is so easy to design three-dimensional in CADvent. I will show you in a second that you can have real values and immediately see if the system will fit into your building or not. Afterwards, you can present the system in 3D, 2D, or 1D, whatever you like. But these are the main informations. And what you should know as well is that the calculation standards are fit to the most local standards in Europe. Please ask our people on site if it works in your country. Currently, CADvent is working on AutoCAD 2012 to 2016. All the products we use can be selected in easy selection fields, and all the technical data, for example, for diffusers, dampers, and silencers, are available in diagrams, so you can easily find the right type of products, and you can also read the values in the selection fields. Okay, let's come to a real project. This big office here is something I like to show you how to start with. You can see in this drawing there's already something designed in CADvent, but I'll start here in this big office. How to design the diffusers in this? Hereby I use the help from our tool Lindquist. www.lindquist.com is our online selection tool. It's free to use. And in this tool you can design rooms, completely projects coming from AutoCAD, but this is something I'll show in another YouTube video. This room here has been designed in AutoCAD, has been uploaded to Lindquist. Then I've selected the right diffusers. I can select them, I can size them, I can simulate what happens in the room. Here we can see in a kind of smog what will happen in this room. And then you can see here the room is completely ventilated, which is exactly what we want, but we do not overload the room with too high velocities. It's just 0.19 meters per second. So this selection is the right one, LKP 315 plus MBBV box with a connection 200. Sound-wise, it's also no problem. Here we can see the green and the red area. Red means in this case just 27 decibels. Green means 26 decibels. Somewhere in between on the occupied zone height is our sound levels. So everything is absolute in a green range, we can say. Good. This is what we want to do. Jumping back to CADvent on AutoCAD. Now I use our Comfort Express. That is the selection area for diffusers. I just jump in and say, okay, we have here a selection of all the different types of diffusers in the Lindab product range. In this case, we go for VAV Pascal solution, and we have selected LKP MBBV box in size 315 with a 200 millimeter connection. This one, 120 liters per second. Now we know this device has a range between 40 and 1216 Pascal. That's a balancing area. That's strange. But this will create between 28 and 53 decibels in sound power. 53 is definitely too much. So if I have a room where I allow not more than 35 decibels, and I can create the room here in a quite easy way, then we can see immediately that we can still use a damper up to 274 Pascal to not overload the room with too high sound levels. So all of this will be taken into account in the calculations of CADvent. Now I select 3.40 meters as a installation height. Now I can press OK, and then the device will be connected to my mouse, and just placing them here with a standard AutoCAD clicks and I can place them, rotate them, that the connection is in the right direction. Oh, no, we have a window here. We cannot go into that window, so I go a bit down here. Okay, and this one has to be moved to the same place here, so I just move it a bit upwards, that we have the right directions. Okie doke. Now we can connect them to the system. That's quite simple. You see I have already a duct here. I can use a cross, and the cross means I can place a T-piece wherever I like here. Click in the right direction, and now you see this colored lines here. The color lines show all standard angles: 90 degrees, 60, 45, 30, 15, and straight. So clicking with the mouse in one of these directions will immediately create an angle, and the duct will follow exactly to the point that you clicked on. So when I click here, it automatically follows my mouse. I can use also everything in 3D. So we have some subcommands with the right mouse click. So for example, the height is more or less elevation. Now my duct is on 3.5 meters. If I want to go upwards, I can put in a new size like 4 meters, and automatically I will get the question which angle I like to use, and it will only show that angles which are possible to go upwards to that specific area, to that specific height. 90 degrees is good. I click enter, and then you will see I have done a vertical duct upwards here. So immediately it goes upwards. And now in 3D you can see what I'm doing, so I can go onwards. And if I want to change sizes, for example, I just click here size, then I can say the new size 200, and automatically creates a reducer. If I want to make a rectangular duct, I can also say size rectangular. Then I can say what is the height of the rectangular. It's 200 millimeters. The width should be 400, and it will automatically create rectangular ducts, and I can go on designing in rectangular. But in our case here, we want to make it as real as possible. I just go back. I delete these parts here, not too much, so we do it like this. Going back to our top view. And in the top view, I can now delete the ducts here again. So how to connect it now? It's quite simple. I mean, connecting 2 points, 2 open ends it's a simple command. I can just say, please connect 2 open ends, and then I click on the first end and the second end. Inside CADvent, we have the functionalities to say that we want to connect air devices with flexible ducts, and the length of the flexible duct should be not more than 800 millimeters. And this function is used when I connect 2 devices like here only one time. So what I have to do is I delete this piece of duct and use the same function once again. Click this device with that nipple, and automatically it creates it here as well with flexible ducts. Now I can say, please connect this open end here with a T-piece to this, and automatically it creates here a connection. But now we can see that there's a difference in height, because this duct here has a height, I will show it here, on 3.6 meters, and this duct here has 3.5 meters. So we use an angle, but this angle is not necessary. We are using flexible ducts. So I delete this again. You see how fast it is. Click on this duct and say this duct should be only 3.5 meters in height. And then when I create again the T-piece, it connects immediately straight. So how to connect here? It's the same way. I can do it in 2 ways. First of all, I could say 1 T-piece here and 1 T-piece here. Once again, 1 T-piece here. So that's one way to do it. Not so nice, but possible. The other way is we can do it immediately, that we say this one here should be connected with a T-piece here. Then we change the T-piece into a cross piece, going up to here, and then the join endpoint command that we know already connected here. So it's rather fast to design in CADvent, to move things. And as I mentioned already, it's simple to move components. It automatically uses the flexibility in ducts because the length is not fit here. And flexible ducts are fully flexible. A flexible duct will automatically be used flexible. So same when I move the device, if I want to the flexible ducts will automatically be adjusted. Okay, now we want to connect these devices here as well. Quite simple. I just go up here with a bend. Maybe we're going down to here, going in this direction, going upwards, and now connecting these components again. I could do it also that if I want to use more flexible ducts, I can do it also immediately that I connect two components with the flexible ducts. If that, for example, if is your need, you can go in here and say, please connect this device with a T-piece flexible. It's possible. Everything is possible. Taking the band, making it as a T-piece, going up here, going straight away, going in this direction here again. Oh, my snap is not activated. And using the flexible ducts again. Oops. Flexible between these two components. And now we do it here as well. So just use a flexible connection here. Oops, that was not good. Making it like this. And here, if we want to, we could use it also flexible. You see, I'm not really exact now here in my design tools, just to show you what's possible here in CADvent. Now we could move also the nipple here, and you see the flexible will automatically adjust it. If I don't want to use this piece of duct here, I can also move this duct to this end. Now you see there are two arrows at the open ends here, and this is a feature that these are not connected now, but there's an easy feature that says repair connections, and when I use that button, it automatically finds open ends that are in front of each other which can be connected, and automatically this will be repaired. It's not nice what I've done here now, but you see how fast and quick it is. Now let's have a look at the sizing. We see that all the ducts have no real sizes. We have a sizing functionality in CADvent, which shows you, let me activate it. It's now on the second screen here, which has multiple sizing functionalities. I will use maximum velocity. Then I can select the maximum velocity in main ducts and in terminal ducts. Terminal ducts are the ducts going directly to an air terminal or air device. But this 3 meters per second can be deactivated if I use this option here, which says that the terminal duct sizes should be according to the terminal connections. So if I've connected a terminal in size 200, then it takes a duct in 200. Of course, this is real life how it will be used. For the sizing, I can activate and deactivate some sizes. You know that air duct systems can be selected in multiple sizes. You can activate and deactivate them if you want them. And we have also sizing functionalities for the rectangular ducts. I will not go too deep into that now. It's just to show what we have in possibilities. With these sizing functions, I say to the system, please size now. So, and you see, there is no tree, it says. No tree means I have no start point. Here's an open end. This open end can be can get a signal to be used as a start point, and this is this symbol here. And now the system knows, here the air gets in or gets out, depends on supplier or extract. And now I can go and say, please size my system. And based on my sizing methods, it will automatically size the system. Based on this method, it will take automatically T-pieces, it will take automatically reducers. Everything is done automatically, and everything is real dimensions. And here we see now from the sizing, everything is moved to the wall. It's rather simple to move it now a bit upwards. I can do it here or here. I don't want to use the snap function, so now it should work. Here maybe as well. Now it's working. So quite simple. If that is done, we can also calculate the system. That is a calculator here. You can just click on the system and you will immediately get a calculation window. And now we have two possibilities to simulate the system. Simulating means we will not adjust the system. We will just blow in air and see what happens then. This can be seen on the pressure results here and the balancing results. When the pressure result is popping up, you will see that there's two different information. There's a nominal flow and there's a real flow. And the difference is coming from the non-balanced system. So we'll see instead of 78 liters per second, we get 82. And there are multiple pages now, and you can see immediately on each device how much influence will sizing have or not. But we want to have a balanced system, so we click the calculate button, and calculation means that everything is balanced now, and the balancing informations will be seen here. So now we see that the nominal flow and the used flow will be the same. Question, why do we have here red numbers? Why is there a deviation between the nominal and the real? Leakage. Every system can have a leakage. We can calculate with leakage inside the systems, and we can give a leakage class, and based on the leakage class, it calculates how much real leakage you will have based on pressure drop inside the system. If you have a sound at the start of the system, we can make also a complete sound calculation. And to do so, I will connect the systems here now to say, please connect the ducts with the rectangular duct here. And we see here we have a handling unit already. And this handling unit has already predefined sound value. So let's do the system calculation here for the complete system. I calculate the system 3010 liters per second, 324 Pascal. This is a sound at the start point at the handling unit. And after this calculation, we will see that there is a sound report. It's now on the second screen. Here we see it. And the sound report shows you multiple sound formations, sound power level after the component, sound generations, component attenuation and required attenuation. In the last row, you can say more or less the most important. This shows if you have a deviation between the allowed sound levels and the current sound levels. And if it is zero, like for example on this position here, then we have no problems. On other positions, we have some requirements. So we know there is a sound problem in the system. This sound problem can be detected, for example, by the analysis function. The analyze function is a table where you can see here. So as soon as I click now on a component, you can see the component here. And this can be analyzed also for sound levels and sound required attenuation. So if I search now for the points where we have a attenuation requirement, so let's turn it like this. So we see these areas here is with sound requirements. Then I can see also immediately the devices here, searching for that. For example, here we have a device. I make a double click in the table will automatically jump to that devices. So in this area, we have a sound problem, and I guess it is the area here. So I will like to add two silencers here. Therefore, I use our DIM silencer. Clicking on the duct, DIM silencer opens immediately. DIM silencer is a separate product selection tool, a silencer selection tool, which in this case is connected to CADvent, and it takes automatically the sound in front of the silencer, the allowed sound after the silencer, flow, speed, connection size, and the length that's available here. I go one size below just to find to see if we can find a silencer. No silencer found that suits to that requirements. I still take a rectangular silencer here with a round connection and a buffle inside. I transfer this to CADvent. Immediately when I do so, it takes automatically reducers. And now we have here a sound requirement in this device that I've selected here. I just make a double click again. To that device, and we see it is 7, 8, 10, 1, 2. And now when I make a new calculation of the system, you couldn't see it, it's on the second window now, we will see that there's just a rest information of 1 decibels and 125 hertz. So this silencer seems to be okay. 1 decibel too much. I think it's acceptable. We keep it like it is right now. Otherwise, I could have a second silencer and then we would solve that problem. But we keep it like it is right now. And finally, I like to show you the bill of material functions. As I mentioned before, CADvent is extremely exact in all the details. So what we have before we go for bill of material, we should go for connectors, because everything you designed here needs connectors mostly. So we have, for example, the possibility to say what is our straight duct length, a standard straight duct length, a standard rectangular duct length. We can say we want to have fitting to fitting couplings inside. We want to have duct to duct couplings inside. Rectangular couplings should be also included. What type of flange type we want to use. You have, for example, different clips for transfer systems. So we say, okay, yes, please delete all existing connectors in the drawing and create new ones. So now you see every connector here is every 3 meters. That makes the duct really exact. You can go also into the rectangular, into the round, and say, okay, this is a really short type of rectangular duct. I don't want to buy this. I can make a prolonging of the leg lengths. There are automatically functions for that, and so on and so on. So it is really, really professional tool for real ordering of products. Finally, let's go to the bill of material. In the bill of material, you can select what type of product should be on the bill of material. You can say, please use a sum of all products or make it really in detail lengths. Should I have it in Excel or should I have it in an internal report? I just start here the Excel report. Excel is starting now on the second page. So jumping, make it up. So we have different sites here, which we'll see now. I haven't marked the products. That's my small mistake here. I do it once more. I say, please make a bill of material from all products we have here on the drawing. Once more, jumping up here, saying rectangular, saying making it in Excel. And now we see immediately that we have a complete list of components here, amount of the components, how many of them, what type. MF is our muffer, it's connector between fittings, then we have nipples, then we have reducers, then we have T-pieces, spiral ducts in 3 meter lengths, there's the rectangular ducts on the second page with all the different types and sizes. According to the standards, this is, for example, now a German drawing with the German DIN standard. But if you have other countries, then you have, of course, country-specific namings of the rectangular products and local uh, requirements, for example, square meter calculations and so on. Okay, now more or less you have seen the most of the features. There are some smaller features like insulation. You can add insulations to the ductworks, of course. You can add own components to the ductworks. I think I should show the nice, smart, and really fast texting functionalities here as well as the last point. Therefore, I deactivate the Xref because the texting, the full automatic texting function in CADvent is searching for free areas for the texting. And that means as more features, as more details the drawing has, as heavier it is, the longer it takes for CADvent to find text. So therefore, I deactivate the Xref. Then I said, please make an auto texting. Text, please, the supply system. Search for free text. And now it takes a few seconds until the system is fully texted. You see the text is finding a free area. I will stop the video now for a second. Here we are. So this all in all took now around 1.5 minutes. So you see there is a texting, but you can define your texting by yourself. For example, I have a full texting here. That means all the diffusers get a lot of information like flow, damping. You see this is 47, 48 Pascal. Everything is balanced here. The sound levels we have here, it's the sound power levels, by the way. So don't wonder that we have 37 decibels. So you can choose whatever you want in the texting based on variables. We can make a coloring system so you can see, for example, sound problems in components by color if you want. Or CADvent is a lot of open and free and flexible tool. You can show everything in 3D like we see here. I can turn it now a bit. That you see it is a 3D system. It's rather simple to make a 3D or a 2D view. You see everything is in 3D. We can shade the system, of course, conceptual shading. You can choose the spiral ducts, but I can also jump into a 2D view. This is also quite flexible. You can use different colors, different layers to show this system. You can fill it, you can shade it, you can leave it open. You can have an external reference to this 2D view. Everything of that is possible. I go back to the top view, so now you can see how it works here. So we are quite flexible and fast in CADvent. I hope you enjoyed this little presentation. If you have more questions, definitely I can show you more information you can find under lindab.com, as well your contact persons. And now I say thank you very much for listening to me this minutes. I hope you enjoyed it, and you will find your contact person for CADvent under lindab.com. Thank you very much. Bye.